I've got this thing of beauty. It's a piece of art, really. This is the Cavium Thunder X2 ARM-based server from Gigabyte. It's the R281-T91. I got that right. I got the model right. The R281-T91, this is an exciting piece of machinery because this is, I mean, it's kind of it's sort of a piece of history, except that it's not a part of history yet, but it will be. It's a game changer. It's an ARM server, 56 cores, 224 threads in this monster. I've got it configured with 512 gigabytes of memory and 16 terabytes of flash. Yeah, we're gonna do some benchmarking. It's gonna be glorious. This is a 2U server from Gigabyte, and fast ARM processors are here. It's actually a second generation server, and second generation means that they've got all the bugs worked out. They've ironed out all the kinks and basically everything is working okay. And there's a ton of lessons learned that have been incorporated into this hardware because I've been following Cavium for a while. I mean, their original Thunder X CPUs were really good. I mean, they were shockingly good. They didn't exactly take the industry by storm, but they didn't, no wind was taken out of their sails. They're coming at it full tilt with these new 28 core CPUs. And also I think there's new 32 core CPUs that are coming out. So the CPUs here are the CN9975, and a lot of bottlenecks and performance constraints from those first gen CPUs have been completely eliminated. And now we've got this glorious machine. I mean, this thing is ridiculous. It is utterly insane. ARM really shines in this chassis. Gigabyte has outdone themselves putting this together in this chassis. I was really shocked at how well that it worked for the test workloads that I did. I mean, the Thunder X2s are up to 3 times faster than the Thunder X CPUs for some workloads. Anintech did a great article that was a super deep dive on this platform and the things that Cavium was doing, and Gigabyte has, sewn it together and put a little bow on it right here in 2U. So this thing is nuts. Now our setup here is pretty swanky. We've got 512 gigabytes of memory, 16 terabytes of flash, although I varied it a little bit. I also ran it with 64 gigabytes of memory just to see how it would do. And boy, let me tell you, this thing is a Linux monster. Let's take a look at the hardware that I've got laid out in front of me. Well, this is the Gigabyte R281-T91. It's really got a lot of lessons learned from Gigabyte in terms of their server division. If you didn't know, Gigabyte actually makes servers. They OEM for a lot of people, and they make a lot of really awesome high-end hardware. This included, it's 2U rack mount. The rails were included in the kit that I chose. We've got two 2.5-inch SATA bays at the rear, although it is configurable. You've got some options if you don't want to use the SATA interface. You've got the little breakout board at the back and the connectors if you want to use it with a SAS controller or something like that. Then we've also got the 24 2.5-inch bays at the front with the SAS 3008 controller. That is sort of gone into a SAS expander backplane, so you've got multiple redundant routes to your 8 channels on your onboard controller. And then of course it's 8 channels of DDR4 2666. That's what it's designed to work with. Now there's memory on the QVL, and it is 8 channels per socket, although it runs just fine. If you want to run 2 sticks of memory per socket, that was the minimal configuration that I tested, but I did do a lot of my testing with 512 gigabytes of memory. That was in the optimal 8 channels per socket configuration. There are some extra sockets, so you can run a little bit more than 8 sticks of memory per socket, so you can run up to 1.5 terabytes of RAM if you really want to. Now the CPUs in this particular chassis, 56 cores, 224 threads. And there's also 56 PCIe 3 Gen 3 lanes that are provided in the chassis. Now it's broken up into X8 and X16, and you also have an X16 OCP Gen 3 mezzanine slot. So you've got a lot of options for expansion, including 25, 50, and 100 gig Ethernet. On board, you've got 2 SFP Plus 28 connections, but you can add an SFP 28. So you've got a lot of options even before you start entering into your expansion slot usage, your regular PCIe expansion slot usage. There are 8 slots, 2 half height and 6 full height, and you can configure how you want your lanes broken up. By default, you get by 16 on the riser cards, but there are by 8 options, and you can split the by 16 into by 8 by 8. And then of course there's a bottom slot that is also by 8 all the time. Now, if you're not new to the game with ARM servers and ARM CPUs, this is ARM Server Ready Certified. It's a certification you look for. The SBSA, SBSR, they try to offer seamless interoperability with operating systems and software. More on that in a moment, but this is certified with, compatible. Now, in terms of IP management, it has built-in ASPEED AST2500, which is industry standard. It's got built-in VGA, serial out. There's also a dedicated RTL8211E physical interface for the management network. And then UEFI does support configuring a shared VLAN on the QL41102 controller so that the ASPEED can work through the onboard SFP Plus ports, although you've got to fiddle with it a little bit more on that in a second. Now, it should be noted that there is a built-in SAS expander at the 2.5-inch backplane bay, as I was saying before. But even if you're running, all 2.5-inch flash, in terms of like a software-defined storage configuration or something like that, you've got plenty of options, plenty of bandwidth. So in short, there's a ton of PCI connectivity here on this board. There are a number of 12-volt breakout headers as well, which will in the future support external power for high current peripherals, things like, Fusion IO, PCIe flash cards, where we're talking, 20, 40 terabytes of flash on the card, graphics cards, things like that. But be sure to check the QVL list. Now, note that officially, graphics cards are not yet supported on the ARM platform here with Cavium. Now, Cavium is working on that though, and I will confess that I've had no problems using it sort of off-label, but it is an off-label use, and so caution. Cool. What can you do with all this hardware? Well, let's talk about workloads. Now, this video, I'm only going to focus on a couple of different workloads. I've got some other videos planned, but there's going to be some opportunity for audience participation. For this system, I tested Ubuntu 18.04 and Red Hat Enterprise Linux 7. I do have plans to test FreeBSD, but not in this video. So be sure you subscribe to our Linux channel where, unironically, we will have FreeBSD testing and more info on the server. Probably shouldn't have called it the Linux channel. Probably should have called it the open source channel. Well, now that I've embarrassed myself, we can move on. So in short, this thing is beastly. I mean, it is utterly beastly. It is nuts. I mean, it's an ARM server and, servers and that kind of thing, but testing Apache, Nginx, PHP, PostgreSQL, MySQL, this hardware really stretches its legs. It is no slouch for those kinds of workloads. Now, I set up a simple striped mirror with the 8 SanDisk 2 terabyte SSDs that I used, and I had no trouble saturating even 40 gigabit Ethernet with that disk setup. I also tested ZFS. ZFS works really well. ZFS in a mirrored configuration, RAID Z2, 2 VDEVs and the RAID Z2, so probably a little overkill because the SSDs probably aren't going to die. There's a lot of stuff in the SSD to give you advance warning that it's going to die, but so, RAID Z1 probably is okay. But, as we can see here in the benchmarks, especially with tasks like massively parallel PHP execution, the difference between the 4-channel 64 gig config and the 16-channel 512 gig configuration is pretty significant. So I tested it with both because you've got so many CPUs keeping the CPUs fed. You got 8 channels. It's like 2 channels per group of CPU, sort of, kind of. You got to look at the topology and sort of, figure that out. But one cool thing about ARM CPUs is that they support 4 threads per core. So for web server type workloads, this scales really well, or at least it seems to. We've got 224 threads to work with on our 2 × 28 core CPUs. So check out my HTOP, and yeah, it's nuts. It's completely nuts. And you can compare this with the 1 thread per core performance for the same benchmark on the same system, at least using the Phoronix test suite. So you can see a pretty significant difference there. And overall, there's actually a lot more interesting information in these benchmarks that it will make a little bit more sense to cover probably in a follow-up video. So before you dive in and click the benchmarks and you're just looking at graphs and it's like, this graph is not as big as that graph. Therefore, be careful about conclusions that you're drawing from the benchmarks. We got to have a separate conversation about that. Because take for example, the PHP bench. I'm scoring around 100,000, but wait, an Intel i7 7700K can score 7 million? It's like, well, no, there's there's more to it going on than that. So I used the Phoronix test suite, and I really didn't do any optimization or really any configuration or anything. I just ran it so that I could have some baseline numbers. And if we want to compare it to, say, like the Amazon ARM instances from the Phoronix database, we can, but it's not really an apples to apples comparison, because those ARM instances on Amazon, they only go up to like 8 or 16 CPUs, 32 gigs of RAM. That's not really a straight comparison. There's also some performance benefits from running in a virtual machine as opposed to bare metal. And with the cores, with the configuration that we're running here, we're talking about 4 threads per core. So for my experience and for the follow-up video, we've also got real world benchmarking with Nginx and Apache and PHP and real world workloads. But single thread, I mean, we've got 2 CPU sockets, 28 cores each, and the PHP bench performance, even if you take that with a grain of salt, the PHP bench performance is about equal to a Xeon E5 2673 V3. We're talking V3 levels of Xeon parity for this one particular benchmark. That is darned impressive for the price point. And that's why we have to have sort of a holistic conversation. Because if you look at this, you're like, well, wait a minute, this one is way faster, or this one is much slower. That's not the whole conversation. So just grain of salt, further discussions need to be had. Just wanted to call that out and be explicit. Now let's talk about power management. For power management, ARM, you would think, would be the king. Yeah, basically it is. It was pretty impressive. The Gigabyte server platform was configured with 2 1200 watt hot swap power supplies, but the system would idle around 200 watts. And in our 18-hour, sort of benchmark stress testing runs for power testing, where we were just sort of pegging the CPU as much as we could, we were getting about 450 watts plus or minus, and the 450 watts was with the 64 gigabytes of memory configuration. Moving that up to 512 gigabytes, we would be using about another 100 watts of electricity, of course. If I add the 8 2 terabyte SSDs and have them doing a bunch of stuff while we're doing that, well, we're increasing the power usage significantly. But this chassis is set up with a 1200 watt power supply so that you can run high power demand PCI Express peripherals and I/O and a network. I mean, you throw a couple of 100 gig network cards in here, and yeah, it's going to generate some heat. It's going to use some power. That's just how we roll. The motherboard does also have provisions for providing full length PCIe slots with power. Yeah, the PCI Express power comes off of the motherboard from little pigtail daughter cable things. And so, that's going to be important once GPUs from vendors like AMD and NVIDIA and Intel, wink, wink, nudge, nudge, say no more. It's going to be important once the vendors for GPUs have been qualified and added to the QVL list as compatible for the platform. Officially, the GPUs, the PCI Express peripherals, you really have to check the QVL list. I mean, it might happen to work anyway, but don't count on it. Don't create support tickets. Don't tell them that I told you to do that, because it is frowned upon. I used a lot of PCI Express peripherals. I had no problems, but that is not a sanctioned use. So the rear 2.5-inch SSD trays are really best for setting up your operating system. It makes it super convenient because, if you've got the 24 drives in the front and it's coming off that SAS 3008 controller, it can be a little problematic to get everything set up and working just fine. So use the rear bays for a simple RAID 1 for your operating system. That would be my recommendation, because you'll have an easier time booting it. The UEFI will have an easier time dealing with it. I guess you could boot from USB if you really wanted to, and that would work fine, but there you go. The IPMI is also very competent. It provides an HTML5 interface and virtual media all over HTML5. JavaScript works great with Chrome and Firefox. No Flash, no janky Java, nothing. It works really well. Now, being a 2U server, 2U rack mount server with my rails, the internal layout is really well designed in terms of airflow and in terms of room for large PCI Express peripherals. So not only do you have the power delivery, you've got plenty of room for full height, even triple height graphics cards, if that's how you're going to roll with this particular setup. Now let's talk quirks and weird problems encountered, because there's this like giddy childlike joy, but then it's like he keeps saying things and it's like, there's some stuff there. It's honestly not a big deal. First, power on self-test on this box, it takes forever. It takes minutes and minutes just to go through all the startup, even on a warm boot. So if you need to reboot your box for a kernel update, it's going to be a 5 to 10 minute process. That's been improved twice with firmware updates since I've been testing this, but they still have a ways to go. Now the PCIe slots here are glorious. We've got a by 16 slot and then 2 by 8s. So this by 16 will run it by 16, but if you want to run it by 8, that'll free up this middle slot. So you can run 3 devices here, or one device at by 16 and another device at by 8. That's pretty awesome. The wrinkle here is that this PCI Express layout, you got the little PCI Express switches. You change it by changing dip switches on the motherboard. It's not automatic. And so, you know, because of the long post times, I had trouble knowing whether I was having trouble with the USB drive or I got the dip switches wrong when I shoved a peripheral in or anything like that. But then once I understood what was happening, it was like, oh, the PCI Express peripherals are configured via these dip switches. No problem. And that seems a little archaic, but having worked on servers a long time, auto detect is the devil. And so I don't want honestly, it's like I would love to have dip switches so I can just configure it and it doesn't figure it out. So the other piece of advice I would have for you is to stick to the QVL. I've got a Micron reference kit, 128 gigabytes, and it would boot and it would work and the system was fine. But if you entered the UEFI, the system would hang. One cool little detail with these PCI Express slots is that the end of the bottom slot, the by 8 slot here, is open. So if you've got a by 16 device, you can shove it in here. Even though it's only physically by 8, the card will just hang out off the end. That's actually a cool feature. Now I would say that because this is a second generation product, you are venturing off the beaten path much less than you were perhaps with a first generation product. If your workload makes sense, from 28 core ARM CPU, 8 memory channels, you really owe it to yourself to pick up one of these, at least for experimentation purposes. You might be shocked at just how much money and time and complexity you can save by going with the ARM platform overall. I mean, ARM is really, if it makes sense for your workload and you're not too dependent on proprietary software, it's really it is shockingly good. You know, for the IPMI, some people prefer the IPMI not to be accessible through the physical interface, or through its own physical interface, but through a VLAN on the SFP Plus ports or through, you know, another integrated connector. I had some trouble with that, but ultimately it was fixed in a firmware update. So if you have trouble with that, be sure that you're running the latest firmware updates on this platform in order to make sure that you can access the IPMI on a VLAN through the SFP Plus interface or the SFP28 interface, depending on what mezzanine cards you've got. So now, when physically reconfiguring the RAM, another weird thing that I ran into was the IPMI would report that it still had 512 gigs of RAM, even after I'd taken most of it out and it was down to 64 gigs. So I'm not really sure what that's about. It would also do that with the storage too. Like I'd reconfigure the storage and it would be like, here's all your storage. And it's like, that was like an hour ago. So I don't really think this would be a real world problem. It's just a quirk from crazy people like me that are reconfiguring constantly. I figured that when the IPMI was booting and it was taking, you know, the 5-minute startup time, that the IPMI was, you know, rescanning the system or whatever, but I don't know. So I'm looking forward to testing FreeBSD, and so far that's not been fun because of the boot time and the boot issue, and sometimes it would just boot to a blinking cursor, and I haven't quite figured that out yet, but I think it's going to be okay with the firmware updates. I haven't revisited it since the last set of firmware updates. So I think it's going to be okay. There were also some performance issues with the serial attached SCSI SSDs. I used SG format to format the SSDs, so you know I went back and forth between 520 byte sectors and 512 byte sectors because these SAS SSDs support that. It's a storage thing, software defined storage. You get into different programs that'll store some CRC information in the other 8 bytes or whatever, but ultimately I just went with ZFS. Now ZFS on ARM, you have to jump through some hoops to get that working on Red Hat on the ARM platform. So it's not quite there yet. It's not quite a package installation thing. And hot plug was a problem with the SAS 3008. So like one hot plug problem that I ran into was I simulated an SSD failure, took the SSD out, replaced it with another 2 terabyte SSD that was, you know, brand new, zeroed, and all this kind of stuff. And the SSD was never made accessible. Like it was never, you could never write to it. But if I took that SSD and inserted it into another slot, that did hot plug fine. I was able to add it, but the replacement, for some reason, I had trouble. I also had trouble with package availability. So because ARM's new in Red Hat Enterprise Linux 7, even though ARM is a platform, not all the packages were there. I tried to install Go, for example. And there is a known issue with Go on Red Hat on ARM. There's a bug for it in Red Hat's bug tracker. So I couldn't install Go to do testing. Well, I could, but I would have had to jump through a lot more hoops. So I'm probably going to be tearing into that and FreeBSD by the time you're watching this video. So stay tuned on the Linux channel for all that shenanigans. And finally, if you work in the data center and you have something that ARM might be good for, reach out, come to the Level 1 Techs forums. Let me know what you're working on because I'm genuinely very curious to know. I mean, Oracle has announced support for this platform, and based on what we've seen in the benchmarks, it would make an excellent system to be part of a database cluster. So it totally makes sense why Oracle is supporting this platform. They can squeeze that much more profit out of their, database customers running a platform like this because it is insanely powerful. I'm giddy having gotten to play with this. So, in conclusion, my final thoughts on this thing are, it almost seems like it's too good to be true. It's like, what's the gotcha? What's the catch? I mean, when Cavium originally launched the Thunder CPUs a number of years ago, ARM servers, they were more of a developer platform. If you were a developer and you were willing to do the work, you could leverage ARM. Chances are you're still running those ARM servers today, and you are extremely happy with them. This is a second generation product where they've improved everything. Nothing has been sacrificed, and there's a ton of lessons learned in here. Not only that, but Gigabyte has done an amazing job putting that all together in this chassis. And yeah, it takes a little bit of fiddling because it's a new platform, but goodness gracious, this platform is solid. I mean, it is very impressive. The potential savings and the ease of configuration and the options that it supports, I mean, it's basically a no-brainer. So that's been a quick look at the R281-T91 from Gigabyte. 28 cores per socket, 2 sockets, 224 threads, 16 terabytes of flash, and a half a terabyte of RAM. Yeah, I'm excited. I'm Wendell, I'm signing out, and you can find me in the Level 1 forums.